I would like now to go ahead and introduce our next presenter, which is also virtually, and this is Dr. Anwar Vahed, who will be presenting on DIRISA for open data and open science. Sorry, just one second. Dr.
Thank you.
Okay. I just quickly want to do a very quick introduction, sorry. Dr. Vahed is the director of the Data Intensive Research Initiative of South Africa. He manages the implementation of a national research data infrastructure that supports data-intensive research and coordinates the implementation of policies for research data management, and he has developed a national strategy of research big data in South Africa. Welcome, and please go ahead.
Thank you, and good morning to everyone. And thank you to the organizers for giving this opportunity to present on DIRISA, our activities in terms of open data and open science. As the chair mentioned, my name is Anwar Vahed, and I'm the director of the Data Intensive Research Initiative of South Africa, which is DIRISA for short. I hope my presentation can be seen. Yes?
Thank you.
Yep. So I'm proceeding on the assumption that everyone can see my screen presentation.
Yes, we can see your screen.
The talk today covers, as I mentioned earlier, DIRISA's activities in terms of promotion and enabling open data and open science practices in South Africa. And the content of my talk will first focus on what DIRISA and what NIKI is, and then a few words about a conception that we have about open data and open science, and our view that these paradigms would ultimately lead to what we think of as open minds. Then I'll talk a little bit about global open science activities that we are involved in, and then drilling down a little bit. Our focus will be, this is the main part of the presentation, on the South African Open Science Cloud, which we are now developing. And then drilling further down, I'll speak a little bit about DIRISA's involvement in developing and establishing what is called the South African Open Data Cloud, which is a component of the South African Open Science Cloud. I'll also give some insight into our view of what we call a national tiered data infrastructure. And the idea here is to show how the national data infrastructure fits in and dovetails with other data repositories, both locally and globally. And then lastly, a word on open data management and open access in general. So NIKI's abbreviation for the National Integrated Cyber Infrastructure System. And essentially it comprises three main technological areas called computing services, or CHPC, as you see on the screen there, which is the Center for High Performance Computing. Then we have SANREN, which is the networking services area, providing high bandwidth services to all research institutions in South Africa, including universities and even some colleges as well. So SANREN is providing a minimum, I think, 10 gigabit per second network for all research practitioners in South Africa and further abroad. And then thirdly, the data services are provided by DIRISA. And it is important to note that these areas that there's tight integration among these areas in terms of the services that we provide, support, enablement. And what you see, for example, on the screen are the various areas, thematic domains, if you like to call it that, that we support in terms of the provision of cyber infrastructure for particularly high-end, what we call high-end e-research, nowadays, as it's called nowadays. One very important activity objective that we have is to develop skills and expertise that's necessary along three areas, three categories, if you like. One is in the support and maintenance of cyber infrastructure. Another is in developing the skills, expertise of users in applying or utilizing the services that we provide. And thirdly, we also support and coordinate a number of activities aimed at developing data-intensive research, science skills in general across South Africa. And I'll say a little bit more about that in further slides. Turning now to DIRISA. DIRISA has got 4 key objectives that you see there on the screen. The most important one is that of building what we call a national data infrastructure. And we identify what we call tier 1 nodes and tier 2 nodes. And again, I'll say a little bit more about this particular structure that we are developing for building and maintaining research data infrastructures for the country. Supporting that key objective in the provision of that kind of this kind of data infrastructure, we also have 3 other objectives. And as I mentioned earlier, we are involved in building capacity and skills. In some cases, we offer courses, training, workshops ourselves. In other cases, we coordinate or support other programs run by other organizations or other forums in the country. And I'll give examples of those further on. A very important objective for us is to engage with stakeholders, to understand their needs, to get their inputs, to allow them to influence the strategic direction and operational activities of DIRISA. And to that end, we also coordinate a number of fairly high-profile R&D projects by various consortia or various groupings of institutions and research and universities. And then lastly, most importantly, an important objective of DIRISA is to manage research data in a sound way. And to that end, we provide a number of research data management services, and we are also quite heavily involved in the development of policies and guidelines supporting sound research data management. So this is at the strategic level, the rationale and the objectives of DIRISA. Now turning to open data, open science. Of course, there are quite a number of definitions of open data and open science. There is no formal one, but the one by the OECD is the one that we adopt. And as you can see on the right-hand side, open science covered quite a number of areas. It's not just about the activity of conducting research. It's a lot more Notably, it also involves open education, which is a very interesting aspect of open science. So this is our conception, and for the sake of this presentation, the concept that we adopt in terms of what we think, what we mean by open science. Then, if one looks at publications and information available on the internet, there is a strong case that is made, that has been made for open science. And if one looks at information publications on the internet and elsewhere, then the benefits of open science can be categorized into three main categories. Together with that, there's quite a number of publications showing how open science lead to increased efficiency and increased return, especially on the investment in cyber infrastructure and in data specifically. So it's a fairly well-established case. There's cost-benefit analysis in terms of fair and not fair data, specifically fair being free, accessible, interoperable, and reusable. And there's a strong case that has been built. There's a plethora of publications that prove the case for open science. Essentially, the three categories of, or the benefits of open science can be categorized in three ways. And I summarize that, these 3 bullet points. And firstly, it's got a multiplier effect. We see that opening up data, opening up science leads to better synergy. It also cascades into other areas. For example, if somebody conducts open science in a specific discipline, then invariably other disciplines and practitioners in other disciplines will learn or utilize in some other way the outputs of open science in a different discipline. COVID-19 is a very good example of a multiplier effect. We've seen this where researchers across the world pull together and develop this kind of synergy because of open science largely. And then there's a second category of benefits, which essentially can be summarized by those words: transparency, integrity, and quality, specifically focusing on the outputs of science. And as we know, there has been some concerns about the integrity of some publications, even in highly respected journals. And the argument here is that open science will, to some extent, mitigate that problem. And then thirdly, one of the main advantages and benefits of open science is that of involving citizens, if we like to call them lay persons, in science, and creating a greater awareness of the benefits of the outputs and the outcomes of science in general and research in general. So these benefits are fairly well established. There are many publications that support these benefits. From a global perspective, for example, the leading global organizations concerned with science in general are all supportive and are all urging and they are all encouraging the adoption of open science practices. And if one looks at different countries, especially the more mature, more developed countries in terms of science, there are quite a number of examples or instances of the implementation of an open science strategy, and it becoming a sort of a requirement nowadays for practitioners to adopt open science practices. And you see there on the screen some examples of countries and governments who are now fairly they have fairly well developed strategies, and they are implementing those strategies as we speak. Particularly for South Africa is the African Open Science Platform, which comprises a number of African countries as an initiative towards encouraging the adoption, underpinning practices for open science. And again, I'll say a little bit more about that. DIRISA is also quite deeply involved in the Global Open Science Cloud Initiative, and there's a lot of work and discussions right now on federating existing open science platforms. In our case, particularly the African Open Science Platform that we are working towards implementation. So turning now to the South African Open Science Cloud, the activities that we are involved in and some of the precursor events and developments are listed here. In 2018, an open science framework report was released. This was as a result of a dialogue between South Africa and the European Union, and there were several workshops and several events that led to this particular report. And this report details quite a number of recommendations covering quite a number of areas and towards the establishment of open science in South Africa. We are now continuing that dialogue with the European Union, and the intent there is to specifically use the European Open Science Cloud as an exemplar of open science towards the establishment of the South African Open Science Cloud. And the approach there is that we will build on existing resources. We've got the South African Research Cloud, which is already established and utilized by quite a number of users, 114 users at the moment, and quite a number of projects that are being run on the SA Research Cloud. Underpinning that research cloud is also the South African Research Data Infrastructure, remembering that DIRISA is a component of NIKI's. So the research data infrastructure, while it is a component of the research cloud, it also operates independently on its own. And the idea behind this, what we are working on right now, is to expand this data infrastructure to incorporate or to federate into existing data repositories hosted by other organizations, specifically organizations that has a particular thematic focus. Examples of those would be SANSA, South African National Space Agency, SOARS, South Africa Weather Services, and South African Environmental Observation Services, SION, that network. The intent there is to incorporate all of those repositories into some coherent structure, which I will talk about in a moment, which will allow users, practitioners to get access to data to discover data, to make data more visible, especially research data. And then we are also developing policy recommendations at this point. NIKI's or DIRISA is not authorized to implement national policies. But what we do is we influence and we recommend the adoption of policies by government. Then, of course, it's very important to have in place good governance structures at various levels, at global, international level, at continental level, at national level. And much of these governance structures do need the support and the encouragement of key stakeholders at various levels of government. So that is, to some extent, a negotiation process amongst different government representatives at some level, and then negotiation processes or discussions amongst various organizations, national organizations in various countries. And then, of course, when these governance structures and arrangements and agreements are in place, we can then turn to federating other resources, both locally and internationally, into the global open science cloud. We can become part of the global open science cloud, and we can also have structures that feed into the structure that we have in mind for developing an open science cloud for South Africa. And then lastly, it's important, of course, to advocate the adoption and the use of these platforms, open science platforms, especially the adoption of an open science mindset amongst practitioners. And again, I'll speak a little bit about some of the concerns that were raised in terms of open science. So this slide shows a conception or a structuring of various data repositories or data resources at various levels, as I alluded to previously. And we've adopted this concept essentially to have some level of organization and some level of coherence amongst the various data repositories globally and at various levels. And as you can see here, we regard global data resources, such as those provided by the Square Kilometre Array, CERN. These are planetary experiments, and they are managed usually by consortia of countries rather than consortia of individual organizations. So taking a management perspective, we regard tier 0 repositories, global repositories, as those that are managed by groupings of nations or countries or governments. At the tier 1 level, we have individual country level repositories. For example, Australia's got ARDC. In the UK, there are a number of these. And JISC, I think, is probably one of the predominant ones in the UK. The European Union have developed and established UDAT, which is a European Commons for Research Data. And NIKIs would be at that level. So NIKIS is a national infrastructure managing not just data, but also high performance computing resources, as I shown earlier. And if one goes further down, one can identify tier 2 nodes, we call them tier 2 nodes, which may be nodes in specific regions or nodes focused on particular disciplines or groupings of disciplines. For example, in Australia, we have Nectar and ANDS. In South Africa, examples of tier 2 nodes would be SANSA, the Space Agency, SCION, the Environmental Observation Network, and ILIFU is one that was initiated by DIRISA, and essentially this organization comprises a consortium of universities, mostly in the Western Cape region, and they use this particular node, as we call it, data node in the region, focusing on specifically bioinformatics and astronomy. So these individual efforts or lower level efforts, they can also include institutional repositories, and we would categorize those as tier 3 repositories. And if you like, you can drill down further and go right down to the C drive on your desktop or laptop, or flash drive in your pocket as well. So the idea behind this is essentially just to get some level of organization amongst the different levels of data repositories. And we have considered other structures like a network structure and a matrix structure, which was too complicated to really get a good and coherent picture of research data resources at various levels. Now turning to the South African Research Data Cloud, as I mentioned earlier, this is part of a bigger organization, bigger structures, which will be the NIKIS-driven open science cloud. And what is shown here are some of the features and some of the functions provided by the Research Data Cloud. This is available as a web service at the DIRISA data portal. And essentially what happens is what we're building right now are these different services that you see on the screen. There's a subscription tool, subscription service, which allows practitioners, users to register to use this facility. Upon successful registration, a user would get 100 gigabyte of storage that he or she can use to manage and store and share his research data collections reliably. Then there are services that we also provide to the general research community. In other words, you don't have to be a subscribed user. We can allocate digital object identifiers to data sets on request, and there will be a service. This one is not yet developed or implemented yet. A discovery service, which allows users to browse through various catalogs of data collections or to search for a specific data collection. A registered user will have access to a function that allows him or her to upload data to the DIRISA storage facility and to share that data in any way that he or she chooses. we've already developed a data management planning tool specifically for South Africa, and a number of institutions, university has adopted this particular service already, and it allows users to more to manage his or her data in a more organized way. What we're currently also working on is a long-term archive, as we call it, a rather large storage facility that will allow users, will enable users to store their data or preserve their data for a period of 5 to 10 years at least. So this is what we are currently working on. Some of these functions are implemented, they are being used. Others are in development right now. We're also working on phase 2, what we call phase 2, and that is the development of collaborative research environments where users and groups of users can use this facility as a joint research environment to share data and analytics processes, outputs of analytics, share data sets, and to build communities around specific projects and R&D activities. And some of the technologies that we employ there are VMs that we provide to groups of users or users, and other technologies like Jupyter Notebook and scientific workflows for specific domains. Our approach to data is based on the ODI model, access spectrum as it's called, and our default position is fair, and as it says in the FAIR principles, we prefer that data is as open as possible, as close as necessary. And within the data access spectrum, we identified 3 main categories of access. One is completely closed. We recognize the fact that not all data can be open. And at the other extreme, we also encourage users to apply a completely open access model to their data sets. That's at the other extreme. This is an internal, shows an internal arrangement or a structure, cyber infrastructure that we are building right now. Some of these components are already in place and have been used for a number of years already. We've got a prototyping environment where users are allowed to experiment and, as they say, crash and burn various implementations. This is more aimed at the technical user who would like to develop unique, new, novel technologies that can be used in a research environment, research cloud environment. Then we have a staging area which allows for testing to a large extent, and also for staging once a particular implementation, oops, I'm sorry about that. Once a particular implementation has been implemented. And then the public-facing environment is what we call the production cloud. This is now in use for quite a number of areas. The most predominant ones are COVID-19 related services and experiments, bioinformatics, astronomy, and climate change applications. And this is the area where, I'm sorry, what am I doing? This is the area where the public will have access to just for the interest of time, I'm almost done. The things that we are now working on, as I mentioned earlier, the development of policies and governance arrangements. At the technical level, we are also having discussions with various hosts of various data resources about interoperability arrangements, and we're also having discussions about digital object management. We're also planning on expanding our existing cyber infrastructure to accommodate open science better, and of course, we are soliciting funding from various sources. Other activities involve the development of skills and expertise, creating that awareness amongst the research community about the benefits of open science, trying to change mindsets especially, so that there is more traction for adopting open science in South Africa. We think it's urgent simply because most challenges that we face, and most opportunities for that matter, are global, and we can think of the, for example, the Sustainable Development Goals, which is a good summary, a good picture of global challenges and opportunities. And as we can recognize, these challenges are quite common amongst various countries. In conclusion, a number of concerns have been raised about open science. First one is probably the most difficult one, and that is the mindset that data belongs to a particular individual or a particular organization. But if you follow the breadcrumbs, actually most, especially public research data, belongs to the taxpayer. Some of the concerns about that, about releasing data or making data available openly, are issues of accreditation and issues of helicopter science. This is a particular concern about for the less developed countries in terms of research and development. There's also a view that the open science will increase the digital divide, and there's also a counter view that it will decrease the divide. But the concern is mostly focused on the difference between high income and low income countries. And then there are a number of misconceptions in the community. Some equate open science with fast science. It may or may not necessarily be so. And then concerns or misperceptions about a conflict between open science, open data and private data. There is no conflict. It's sometimes it's necessary to explain that in a little bit more detail. And then lastly, there are issues of reliability in terms of releasing data models or analytical methods, algorithms, code prematurely, disseminating them prematurely while they are still not well developed and validated and tested. But this is a two-edged sword in the sense that if you do release these outputs early, then the public can perhaps pick up more easily errors and shortcomings in these outputs. So towards addressing these concerns, what is shown here is the OECD recommendations in terms of research data. And although the word open doesn't appear here, much of this is about open data. And a lot of these activities and initiatives specifically relate to the promotion and the establishment of open data and open science generally.
Excuse me, Dr. Vahed.
So thank you very much. If there are any questions, I'm quite happy to.
Thank you so much.